Okay, this video is about Module 4, and we're going to talk about commonly missed problems from Exam 2. And the big thing is the linear inequalities. There's so many steps involved that it can be difficult for students. So let's take this one step at a time. I've color-coded my equations. So equation 1 is going to be red, and equation or inequality. My inequality 2 is going to be in blue. And if you notice, equation 1 is in y equals mx plus b format, where the slope is right here and the y-intercept is right here. So we can quickly graph from this information. This is not in that format, it's in standard form. So you could solve for y. It's going to take 2 algebraic steps and reversing the symbol, so it's going to be a little bit cumbersome for some people. I'm going to use the method we talked about in other sections where we can do this by finding intercepts. So that way also you get to see 2 different ways of graphing. And so equation 1 like I said, we can see the slope right here. So m is equal to -1, which we need to make this a rise over run. So that's going to be -1 over 1. And then this 5 is the y-intercept, or b. And so this is just going to be 5, which comes from the point 0, 5. Okay, so y equals mx plus b is the format I'm referring to. So let's go ahead and plot this in red. So 1, 2, 3, 4, 5 right here is the y-intercept. And then from there we're going to go down 1 over 1. So down 1 over 1 right here. And we can keep going. So there's your first line. And actually I put it solid, forgot to mention, because there's an equal sign right here. So this one's going to be solid. And we're going to shade down, or below the line. Okay, so why? It's because of the equal sign. And because of the less than sign, we're going to shade below the line. So we're going to shade below the line because we have it, and because y is by itself. Now, if we take a look at equation 2, which is in standard form, we're going to use the intercept method. So if let's start with y. If y is equal to 0, that'll take away the most complicated term. That's going to leave us with x equals 6. So we have the intercept 6, 0. And if x equals 0, then that's going to give us the term -3y is equal to 6, which you can divide both sides by -3, or just think of -3 times -2 is going to be equal to 6. And that way we have x is 0 and y is -2 as an intercept. So we're going to plot those over here. So 1, 2, 3, 4, 6, and 1, 2 down here. And we're going to make this dashed because there is no equal sign. There's no equal sign, therefore it's dashed. Instead of solid. And because y is not by itself, we're going to have to use test points. We're going to test 0, 0. Because if it's true right here at 0, 0, then we're going to shade above the line. If it's false, we're going to shade below the line. So all we're going to do is put in 0 for x and y. And we're going to see if this is true or not. So 0 minus 0. So is this true? 0 is less than 6? Yes, this is true. And if that's true, that means we're going to shade in the region where the 0 is. So we're going to shade above the line. Now the solution region is going to be the overlap of those two regions, which is in this region right here. Okay, our next problem will be about linear programming. And in this case, we have a feasible region and its vertices are shown. And this is made by 4 different inequalities. So there's a line here that was created. There was another line here that was created here and here. So all 4 lines put together, and we enclose the region. It's called a feasible region. And this is what's going to determine our maximum and minimum values. We're going to take a look at the vertices, and so we're going to take each of these vertices and we're going to plug it into the objective function to see which one is the lowest number and which one is the highest number, and that's basically it. So let's get started. First we're going to test out 0, 0. We're going to put in 0, 4. We're going to put in, we're going to put in 2, 3. And 5, 0. So the first one, we're going to put in the 0 here for x and 0 for y. And of course that's going to be 0 plus 0, which is 0. The second one is going to be 0 for x and 4 for y. That's going to give us 0 plus 16, which is 16. Then we're going to put in 2 for x and 3 for y. That's going to give us 12 plus 12, which is 24. Then we're going to do 5 for x and 0 for y, and that's going to give us 30 plus 0, which is 30. Then we can see, okay, the lowest number would be 0 right there, so that would be the minimum, and this is 30 would be the highest number, so that would be the maximum. And that's it.